All right. So let's take care of these problems. So when we look at this one right here, we're going to have to implement two of our rules. Not to use the quotient rule and the chain rule. Now, if it was possible to square this out and make it more easier derivative, then I would go ahead and do it. But because we have a lot going on here, nah, it wouldn't be worth it. We'll be all right. So when you look at the chain rule, I'll probably go with the chain rule first. We need to take the derivative of the outside and then the derivative of the inside. So the easiest part is take the derivative of the outside. In other words, recognizing that we have that power sitting out there. So we bring the 2 down and then subtract 1 from our exponent, which would just be 1. And so that's the first part of the chain rule. Like I said, bring the exponent down, which is 2. Then leave what's inside intact, but then subtract 1 from the exponent. And then we're going to multiply that by the derivative of the inside. Now, when we take the derivative of the inside, that's when we have to use our quotient rule. All right. So doing the quotient rule, we have our top, we can call u. Then derivative of that, which is u prime, that would be 3t squared. Then we have v, which is the bottom. Then derivative of that, v prime, which is going to be 8t to the 7th. So we just bring our exponent down, subtract 1 from the exponent, and then the derivative of any constant will always be 0. All right. So quotient rule is, let's see, derivative uv over derivative of x. So we're looking at vu prime minus uv prime all over v squared. All right, so v is t to the 8th plus 1. U prime is 3t squared. And I'm running out of room, so I'll bring it down bottom. T to the 8th plus 1, 3t squared minus t cubed, 8t to the 7th, all over t to the 8th plus 1 squared. So let's go ahead and distribute, simplify if possible. So 3t squared multiply to each one of these is going to be 3t to the 10th plus 3t squared minus 8t to the 7th. So all we're doing is adding our exponent. I say t to the 7th, 8t to the 10th. So we're just adding our exponents. And we have t to the 8th plus 1 squared down bottom still. We can combine our like terms. 3t to the 10th minus 8t to the 10th. Making sure I got my stuff straight. 10, 10, 3, 3, yeah. All right, so that would be negative 5t to the 10th plus 3t to the 2nd, t to the 8th plus 1 squared. All right, so we can bring that back here. So h prime is going to be 2 t cubed, t to the 8th plus 1 Well, let's go ahead and just multiply that. That's 2t cubed, t to the 8th plus 1. Right? Okay. And then we have negative 5t to the 10th plus 3t to the 5th. I said 5th, to the 2nd over t to the 8th plus 1 squared. So it came from right here. And now we can simplify by just multiplying across. We didn't need this parentheses, but I was just doing it just to signify where our pieces came from. So this t, 2t cubed need to be multiplied to both of those. And we can combine these and to have a final answer of negative 10 t to the 13th. No, there should be a positive 10. Nope, no, I was right, negative. And then positive 6 t to the 5th all over t to the 8th plus 1 to the 3rd power. All right, so let me make sure I got my stuff straight. Negative 10 t to the 13th. That was t cubed. Make sure that was t cubed. I was right. T cubed. Okay, that was on the inside. Okay. So, and then 2 times 3, 6, 3, 5, 3, 2, and 5. And then here, can we simplify? We can factor out t to the 5th. That would have been cool if this was a 5, because then we would really simplify this, but nope, that's it. Okay. Let me know if you have any questions off that one. So let's go to the next one. Okay, the next one is less involved. All right, let me see. Okay, we're good. Okay, so here, chain rule. Now that 4 does not have to be involved. Now we'll go another color. The 4 does not have to be involved with the process. So we can bring that out front. And now once again, we're gonna take the derivative of the outside and then take the derivative of the inside. So the outside, you bring the 3 out front and it's subtract 1 from the exponent. So that'll be 3 times 3 minus 7x squared. Now we multiply by the derivative of the inside, which would just be negative 7. All right. So now we can simplify this. Negative 7 times 3, negative 21. And then 4 times negative 21, negative 84, 3 minus 7x squared. And that should be it. They shouldn't ask you to fold that out or expand the multiplication. So that should be fine. All right, and make sure, bring the 4 out. Because it's just a constant. Now, if you had an x here, then you wouldn't just be able to bring it out. You have to consider the product rule, because you have a variable involved. But since it's just a constant, just bring it out front, deal with the rest, and then bring it back when you're done with your derivative. So bring 3, minus 2. Just make sure I got everything. Yep. So we should be good. And you had one more. All right, so we want to take this or find the derivative of this implicitly. So implicit differentiation, if I can get it out. So in other words, we need to find dy dx. So we need to apply the derivative with respect to x. And I like to start with a different color once I start my process. So you apply the derivative with respect to x to both sides of the equation. So as always, derivative of a constant, no matter what, will go to 0. And then over here, we need to take the derivative of this with respect to x. You see that we have the chain rule that we have to implement once again. You have the 6 on the outside for your exponent, then we have the stuff on the inside that we need to consider. So, but we're doing this implicitly because we're taking the derivative with respect to x, but we do have a y involved. And so at some point, we're going to have dy dx, and we're going to end up solving for that dy dx. Okay. So first thing we'll do is bring down the 6. Leave what's in the parentheses the same. Subtract 1 from your exponent. Now we need to take the derivative of what's going on in the inside. With respect to x. So this part is done. Now we need to take care of this part. Okay. Now taking the derivative of each one of those pieces, since there's a plus sign in between, we can take the derivative of each one of them individually. So cosine pi x derivative of sine pi y. And this is going to produce our dy dx because we have a y in here. Just see in a second. All right, so derivative of cosine is negative sine, but we also have to consider the pi. So it's going to be negative sine pi x times pi plus the derivative of sine, which is cosine pi y. Then derivative of pi y is pi dy dx. All right. So make sure I got my stuff straight. All right, so that's that. And so now we can go ahead and put that right here. Oh yeah, and don't forget that's equal to 0, but we'll bring that here. So probably need to write a little smaller. All right, so now we have this plus sign here. So now we need access to dy dx. And I'm trying to make sure I didn't miss anything. Okay. So we need access to dy dx. So really, what I would do is take this quantity and distribute it. So that's going to be -6 pi. Probably say here, -6 pi sine pi x cosine pi x plus sine pi y to the 5th power plus 6 pi cosine pi y dy dx times cosine pi x plus sine pi y to the 5th power equal to 0. All right. And now I need to get this on the other side of my equation, so I will add that to both sides. It would be good if I could write all this on one line. See if I can get it all on one line so I can. As a matter of fact, I'm just going to call this, I'm just going to write that as the parentheses. Just do that, just so I can shorten it and have it all in one line. As a matter of fact, I'll do it like this. Go back to red. And I'm going to color that blue. Try to color code it and shorten this stuff up. All right, so I need to get this and take it over there. Because remember, we're trying to solve for dy dx. So I'm going to subtract 6 pi sine pi x from both sides. That cancels here. So it's -6 pi cosine pi dy dx. -6 pi. All right. Look like a lot of stuff will cancel for us. Because now we're trying to, once again, solve for dy dx. So we're going to divide both sides by everything except for the dy dx. So this cancels. That leaves me with dy dx. And then we have the 6 pi's cancel. This quantity cancels as well. And that leaves me with sine pi. Hold on. Make sure I didn't lose a minus sign. Yep. Okay. So I should have added something in my mind triggered. So that should be a plus. Because I had negative sign. Yep, -6 pi sine. So I should have added 6 pi sine to both sides. And then here, so that's a plus. So now when I divide, that should be a negative here. Sine pi x. And then over cosine pi y. All the stuff canceled, just making sure. All right, so just like it's the answer. Couldn't simplify this and make it tangent because one is applying sine to pi x and the other one's applying it to sine. I mean, applying the cosine to pi y. Now, if both of them were x, then I could simplify this further and write negative tangent pi x. But that's not the case. So this would be our answer. All right, let me know if you have any questions on anything. Take care.